Good afternoon, grade 4 students. Once again, this is our scientific day with Miss Shara. Today is a cheerful day because of you. Yes, you. Let me read our learning target for today. I can describe the steps of the scientific method and its importance. We can do this by following our work plan. So we will have science bits, unlocking difficulties, discussion time, and a wrap up. So let's think like a scientist. So let's have our science bits for today. It is 2022 monkeypox outbreak.
The World Health Organization, or the WHO, declared monkeypox a global health emergency. According to the WHO, transmission occurs when a person comes into close contact with a virus through an infected animal, infected person, or contaminated environment. The following symptoms of monkeypox are commonly experienced at the beginning of the disease: fever, headache, muscle ache, backache, swollen lymph nodes, chills, general feeling of exhaustion. Symptoms can progress to a rash with red, raised bumps on the skin, which then turns into pus-filled blisters before eventually drying out and falling off. Those who have a travel history in countries with confirmed monkeypox cases and are currently experiencing symptoms were advised to immediately seek medical attention. The World Health Organization, or the WHO, declared monkeypox a global health emergency. According to the WHO, transmission occurs when a person comes into close contact with a virus through an infected animal, infected person, or contaminated environment. The following symptoms of monkeypox are commonly experienced at the beginning of...
So there is an ongoing outbreak of monkeypox. A viral disease was confirmed in May 2022. So the initial cluster of cases was found in the United Kingdom, where the first case was detected on the 6th of May 2022 in an individual with travel links to Nigeria, so where the disease is endemic. The outbreak marked the first time monkeypox has spread widely outside Central and West Africa. From May 18 onwards, cases were reported from an increasing number of countries and regions, predominantly in Europe, but also in North and South America, in Asia, in Africa, and in Oceania. This happens on July 23. The Director General of the World Health Organization, Tedros Adhanom Ghebreyesus, declared the outbreak a public health emergency of international concern. So last August 2, there had been a total of 25,436 confirmed cases in nearly 80 countries that do not typically see cases
of the disease: fever, headache, muscle ache, backache, swollen.
So now let's have an unlocking of difficulties. A sudden rise in the incidence of disease is called an outbreak. So there is a monkeypox outbreak. When it is based on principles of science, we call it as scientific. There is an orderliness of thoughts or behavior, systematic planning or action. It is called a method. Our lesson covered for today is scientific method. This is the foundation of doing science. Science aims for measurable result through testing and analysis. Science is based on fact, not opinion or preferences. The process of science is designed to challenge ideas through research, and we are using scientific method. So here are the questions that you need to take note of. What is the scientific method? What are the steps of the scientific method? Why is the scientific method important to everyday life? Let's think like a scientist. Do you know that each of us are scientists in our own way? We are little scientists. So let's think like a scientist. Let's be like Albert Einstein, who formulated quantum theory of light. That light is a particle or photon. Or be like Charles Babbage, who first automatic digital computer was discovered by him. And then we also have a Filipina scientist. We have Fe del Mundo. Her major breakthroughs is in immunization and in the treatment of jaundice and providing healthcare to thousands of poor families. So maybe one day we are a future scientist. For now, let's think like scientists. What is this scientific method? It refers to the steps used to create an effective experiment. So steps are given in order to expand understanding, to examine and explore an area of interest more interestingly and effectively. So here are the steps in scientific method. So step by step, there is a number. We will start from 1, 2, 3, 4, 5, 6, 7, 8. So you have to do it step by step. So number 1, identifying the problem. 2, referring to authority. 3, asking appropriate question. 4, developing hypothesis. 5, conducting an experiment. 6, keeping records. 7, analyzing the result. 8, developing a conclusion. So these are the step-by-step methods scientifically. So we call this as scientific methods. Now let's recall our science bits.
Today, declaring the U.S. a public health emergency over the nationwide monkeypox outbreak. A senior White House official confirming that to ABC News. We are told this will free up, if you like, additional resources for vaccines, treatment, and the tracking of the spread of this disease. More than 6,600 cases of monkeypox have been reported in the U.S. so far. We will have much more on this as the story develops.
Okay, so once you hear things like this, news from the TV or from the internet, are you just going to let it pass by? Of course, you have to ask questions. You have to identify the problem, asking questions that will assist you in defining a more specific problem. What is this monkeypox? What is she talking about? Now you have to identify the problem. You have to ask questions. Number 2 steps. We have to refer to authority or referring to authority. What is that? These are preparing all the materials and information for the experimentation. So we have the magazine, articles, pamphlets, brochure or online resources, interviews, and personal conversation. So these are things that we can research on, given by authorities or professional people who knows about the topic. we can look at the news. We can search on Google. Ayan, no? So there's a lot of topics or things that we can research on. We can refer to authority. Number 3, you have to ask appropriate question. So number 3 is asking appropriate question. This is formulating a very specific question in mind in the field of interest. It should indicate subjects to be studied. So since we are talking about monkeypox, we heard about monkeypox. How does someone know if they have monkeypox? So that is our question. The next step is developing a hypothesis. So we discussed about hypothesizing. So turning the question to hypothesis. Hypothesis is an educated guess and statement of how scientists thinks the experiment will turn out. So in doing hypothesis or developing a hypothesis, we use if and then statement. So there is an intelligent guess. So if you have fever and muscle ache that develop with flu-like symptoms, then you have monkeypox. So this statement is our hypothesis. After hypothesizing, what are we going to do next? That's right. We do an experiment. So conducting an experiment, the 5th scientific method. Yeah, so we are going to test one's hypothesis. Conducting an experiment is testing one's hypothesis. Yeah, so check if you have fever. Check if you have muscle ache. So you have to conduct an experiment. So conducting an experiment is the heart of scientific method. Testing one's hypothesis is the heart of scientific method. So you have to do experimentation. You have to observe the changes under different conditions. So test or examine one idea at a time. Take note, one idea at a time. Decide how many times to conduct the experiment. The number of subjects being tested. Okay? Duration. Materials needed. So you have to take note of all of this in doing your experiment. The 6th step, of course, is keeping records. So when you do your experiment, you have to gather data. That's why I'm always telling you to have a notebook, and it's keeping records. So all the information that you will gather, do you have fever? Do you have cough? Do you have runny nose? You check. You take note of your temperature. You take note of the pain that you are feeling. Yeah, and you have to keep records. You observe yourself for 1 week or 3 days, things like that. But you have to make sure that you have a complete record. So keeping records is maintaining records of everything during the course of an experiment to provide an accurate summary of the event of an experiment. So before you start your experiment, you put your notebook already there so that you can write whatever you are observing for you to keep records. Of course, the next step, we have to analyze the result. Analyzing the result. So that is the seventh step. So after collecting data, analyze the information. Combine and go over the available results in order to formulate a conclusion. Of course, while doing the experiment, you are writing on the notebook, you have to organize the data that you have collected. So if you can put it in the graph, that's okay. Right? So that you can have an accurate conclusion, or you can formulate a conclusion. The last step is developing conclusion. And after gathering data, analyzing the data, now you can formulate a conclusion. So the conclusion example is like this. I therefore conclude that having fever and muscle aches that develop with flu-like symptoms can be an indicator that you have monkeypox. Of course, you have to consult your doctor so that the doctor can help you confirm if your experimentation result is true and correct. So it's not just only listening to the news and report about monkeypox. You also have to do scientific method. You have to confirm it. Okay po, if it's true or if it's a fact. So developing conclusion provides some answers to the formulated problems. The conclusion represents what you actually learned by conducting the experiment. So if you do not have a fever or if you do not have a muscle pain, that does not mean that your experiment is a failure. So there is nothing wrong if the conclusion does not support the hypothesis. It just means that you can have another experimentation. One of the most important features of the scientific method is its repeatability. So you can do it again and again. The experiments performed to prove a working hypothesis must clearly record all details so that others may replicate them and eventually allow the hypothesis to become widely accepted. Maybe today, your conclusion is not yet accepted, but as time goes by, it can be accepted. So you can do scientific method again and again. It's repeatability. So in summary, scientific methods are steps that we can use to solve our problem every day systematically or scientifically or like a scientist. So the first one is observation. So you have to identify the problem. 2, question. That could be referring to authority or asking appropriate question. And then we have hypothesis. Developing hypothesis for number 4. Number 5, conducting an experiment. And then we have the analysis. So in analysis, we can put the keeping records and analyzing the result together. And after that is the conclusion. So developing conclusion. So scientific method is asking question again and again and finding the solution. Of course, I told you that hypothesizing and experimenting is done in the laboratories. In the laboratory, we have laboratory apparatus. Laboratory equipment is generally used to either perform an experiment or to take measurements and gather data. So after learning scientific method, let's learn about the things that we can use in doing our experiments. Oh wow, so this is the laboratory in Flores. This is our Flores lab, the SSI laboratory. Oh, there's a lot of apparatus in there. Put question mark. What is this apparatus? Let's find out. The first one is the test tube. What is a test tube? And together with the test tube, rock. So test tube holds small amount of liquid and it's used for observation. You cannot put them or just let it stand like that. You need to use a test tube rock. So it holds the test tube to avoid breaking. So these are used for observation purposes. Of course, you need to have a test tube holder. From the name itself, it holds the test tube during heating. Next is the alcohol lamp. Alcohol lamp heats or boil liquid under study. We also have a wire gauze. So it spreads the heat of the burner and prevents and breaking of the objects being heated. Beaker, look at the picture. It holds and measures the amount of liquid and used also for heating. So you can also use beaker for heating just like the test tube. So since we are heating, we have to know the temperature. So we have to use laboratory thermometer. It measures the coldness and hotness of objects. We also have steering rod. It's like a stick. It's a glass stick. So used to steer and or mix mixtures and compounds. Next we have a spatula. Yan, it is used to transfer powdered chemicals to avoid contamination. We also have iron stand. It supports objects to be heated. We have watch glass. Holds small amount of liquids or powder under observation. There is also crucible and cover. What is this? It is used to hold chemicals and powder to be heated. We also have mortar and pestles. It is used to grind and crush chemicals into finer texture. Also used for mixing. Then the glass funnel. It transfers liquids from one container to another. So there is no more question mark. We can identify now the different laboratory apparatus that we can find in our Flores lab. The next question is, what makes an experiment fair? So there are variables in science experiment. So what is a variable? A variable is any factor, trait, or condition that can exist in differing amounts or types. Differing means different, right? So an experiment usually has three kinds of variables. We have the independent, dependent, and controlled. So let's look at this birdy example. Imagine you want to see what color of bird feathers your local birds preferred. So yeah, there's a lot of birds outside flying around. So you want to know which among the color of your bird feathers will attract more birds to eat. So we have to check. So we have red, blue, and green. So let's check the variables. We have three independent variables, dependent variable, and the controlled variable. So from the bird feeder, the color of the feathers is the independent variable. The amount of seed eaten is the dependent variable. And the controlled variables is everything else that is kept the same. For example, the location of the feeders, the kind of feeder used, and putting the feeders out at the same time. So controlled means it's always the same. Let's take a look at it again in our experimental design. So the variables, controlled variables, the location of feeders, kind of seed, type of feeder. The independent variable is the color of the bird's house, red, blue, and green. The dependent variable is the amount of seed eaten. So these are all the same. If everything except the independent variable is held constant, we can say that the experiment is fair. Only the independent variable can change. So that means controlled variable and dependent variable should be constant. Why is it important to change only one thing at a time? If you don't, then you won't know what is causing your results. So it's important to change one thing at a time. To ensure a fair test, a good experiment has only one independent variable. As the scientist, or thinking like a scientist, he changes the independent variable. He or she records the data that they collect. So let's look at the three kinds of variables. Independent variable, dependent variable, controlled or constant variable. Let's define independent variable. So the independent variable is something that is changed by the scientists. So what is tested? What is manipulated? This is the cause. What is dependent variable? The dependent variable, something that might be affected by the change and measured. So the question there is, what is observed? What is measured? The data collected during the investigation. So this is the data that you are collecting from the dependent variable. So the independent variable is the cause. It influences the change in the dependent variable. Controlled variables are quantities or items that you want to remain constant. So a variable that is not changed and stays the same. It is called constants. It allows for a fair test. Look at this one. So these are the different types of variables. We have the independent, dependent, and controlled. So the one thing you change, limit to only one in an experiment, is the independent variable. The liquid used to water each plant. So you can change the liquid, no? So that is your independent variable. So you can use Coke, juice, and water as your independent variable. The dependent variable is the change that happens because of the independent variable. So what is your dependent variable here? The height or the health of the plant. What is the controlled variable or the constant variable? The type of plant used, pot size, and the amount of liquid. Also the soil type. So you put the same plant, 3 pots, A, B, C. Same amount of soil or soil type, A, B, C. Same pot size. And then you will put same amount of liquid. Yan. So depending on the independent variable, the plant can either grow healthy or tall. So the independent variables is the liquid that you are using. In this picture, we have Coke, juice, and water. Wow! So again, another scientific day with Miss Shara. We talk about the scientific method, the step-by-step procedure that we are going to follow when we do an experiment or when we solve a problem. And then the laboratory apparatuses that we are going to use. And of course, the variables, the types of variables, the 3 types of variables that we can see in our experiments. So once again, stay happy, thank you, and stay safe. Bye-bye, grade 4 students. I love you.